Let's solve this integral using trigonometric substitutions. So if you check the table that we have in our notes, the substitution that we should use is x equals a, well in our case 4 is 2 squared, so 2 secant theta. So dx is going to be 2 times secant theta prime d theta, which I'm going to compute as 1 over cosine theta d prime d theta, 2 times using quotient rule, this is going to be sine theta over cosine squared of theta d theta, or 2 times tangent theta secant theta d theta. Another thing that we want to know is what's x squared minus 4 using this substitution. So it's going to be, if we replace x with 2 secant theta, it's going to be 4 secant squared theta minus 4. Factor out the 4, secant squared theta minus 1. Secant squared is 1 over cosine squared of theta minus 1. We can do the algebra here, and if we multiply by cosine squared of theta over cosine squared of theta, we get sine squared of theta over cosine squared of theta, which is 4 tangent squared of theta. So when we replace all this into our integral, it becomes integral of 1 over x squared minus 4, it's 4 tangent squared of theta, and dx is 2 tangent theta secant theta d theta. So tangent theta cancels with this one, 2 with 4, so we get 1 over 2 integral of secant theta over tangent theta d theta. I'm going to change this into sine and cosine to simplify it. So I get 1 over cosine theta times, well, it would be divided by tangent, so it's going to be times cosine theta over sine theta. We do the reciprocal, and these cancel, and we get 1 over 2 integral of cosecant theta d theta. And we already solved this integral in one of the videos, so this is negative 1 over 2 ln of cosecant theta plus cotangent theta plus c. So our integral was in x, so let's replace it back into negative 1 over 2 ln of, well, the substitution that we did was x equals 2 secant theta. So in other words, if I want to find out cosecant theta and cotangent theta, I'm going to draw a triangle, a right triangle, where the acute angle is theta. I have 90 degrees. So secant theta, it's x over 2. Secant, it's 1 over cosine theta, it's x over 2, or cosine theta is 2 over x. So cosine theta is the adjacent over hypotenuse, which means this side here is the hypotenuse squared minus 4. So it's going to be cosecant theta, which is what I highlighted in yellow, is going to be given by 1 over sine theta. Well, sine theta, it's opposite, x squared minus 4, over hypotenuse. So the reciprocal of this is x over square root of x squared minus 4. And if I want to find the cotangent of theta, I'm going to do cotangent is cosine theta over, or we can just say is the adjacent side, which is 2, over the opposite, which is square root of x squared minus 4. So when we replace this back into the form, into the answer, we get cosecant of theta, which is x over square root of x squared minus 4, plus 2 over square root of x squared minus 4 plus c. which I'm going to rewrite here as my final answer, -1/2 ln of x plus 2 over square root of x squared minus 4, absolute value plus c. Can we rewrite this or simplify it? Yeah, we can say -1/2 ln of x plus 2 and then rationalize square root of x squared minus 4 over x squared minus 4, which I'm going to write x minus 2x plus 2 because I can simplify this. So we can get -1/2 ln of square root of x squared minus 4 over x minus 2. We can simplify even more, write -1/2 ln of square root of x squared minus 4 plus 1/2 ln of x minus 2. I'll put the absolute value plus c. This half from here comes in front, so it's -1/4 ln of x squared minus 4 plus 1/2 ln of x minus 2. And we can do all kinds of things. I would say if we stop here, we should be fine.